Okay, next up in our unit on volume and perimeter and area and all those sorts of things is the volume of spheres, and we'll also have a quick look at composite solids. The formula for a sphere is written just here. It is on the formula sheet. Much like all formulas on the formula sheet, they don't give you any context, so make sure you get used to writing it out when you're doing the questions so that you know when to use that formula and you know how to use that formula. So if you're in an exam and you see it on the sheet, you go, that's the one for a sphere. So the other thing you got to remember is when you see the word hemisphere, that's just half the volume of original sphere. So I guess there's not much more to that. You just got to know that particular fact. So all we've got to do is basically use the formula. So some very basic examples here to start with. Once again, write the formula out, substitute, then evaluate. So volume equals 4/3 of pi r cubed. Be very careful there because you're probably very used to writing pi r squared for area. Just bear in mind that it's got to be pi r cubed, and I'll just clean up that 4 a little bit, make it look a bit more like a 4. So we substitute in what we know, 4/3 times pi times, and in this case the radius is 4, so that's 4 cubed, and you just key all of that into your trusty calculator. So 4 over 3 times by pi times by 4 cubed. And that's 268.08. I'll call that 268.1. 268.1 centimeters cubed because it's a volume, and that's to 1 decimal place. Okay, so for the next example, obviously maths teachers, we're not the most interesting people. We think of one way to confuse people and keep doing it the same way every time. And in this particular case, the old classic of giving you the diameter when you need the radiuses in here. This should be pretty easy sort of stuff to spot. It's a mistake you should try to avoid making, but people still do make it even on the HSC exam paper. So I use my formula, I substitute in. With this formula, there's only one thing I need to know, and that's the radius. And the radius of this particular circle is going to be 5 because that's half of the diameter. So I take my calculator. Now, there's a little trick here with the calculator you can use. Rather than having to type all of that garbage in again, I can just go back using the replay button, delete that one number there, because as I said, with this formula, you only need to change that one thing, press equals, and that's got everything I need. So 523.6, we'll call that. 0.6. It's in centimeters, so centimeters cubed, and that's again to 1 decimal place. Okay. So once again, we've got another one to work out. This time it's a hemisphere, so our volume is just going to be half of what we normally have. So half of 4/3 pi r cubed. Okay, so once again, we just need to substitute in just the one value. I don't really need those brackets here, so I won't keep them there. I was just trying to make the point at the start, because multiplication, it doesn't matter what order we do it in. Now my radius here is 12, so I can just key all of that into my calculator. Now, as I said before, it doesn't matter what order multiplication is done in. 2 times 3 is the same as 3 times 2. So for this particular one, I can use that replay button again, save myself a whole lot of time, and choose 12 there, 4/3 times pi times 12 cubed, and then I can then at the end multiply that by 1/2, and that'll all work out just nicely. So that's 3619.1 centimeters cubed, and that's again to 1 decimal place, and away we go. So the next question is a rather simple one. It's just an applied question. So if the Earth was considered roughly spherical with a radius of 6,400 kilometres, what would be the approximate volume of the Earth? So very simple, really. We just use that formula, 4/3 of pi r cubed. The only thing we need to know is that radius. So times pi times by the radius, which is 6,400 cubed. And we can put that into our calculator and it'll come up with a number that's quite big. What I'll do is I'll use this replay button and I'll go back to that previous one I had by pressing the up key. You can scroll through recent calculations you put in. And I'll just change the radius to 6,400. And when I press equals, I'm going to get I'll go with 1.1 times 10 to the 12th. And that's in kilometres cubed. 10 to the 12th means to see it properly, we'd have to move the decimal place 12 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Obviously roughly, because we rounded at this step here, we rounded to one decimal place. So this is an approximation, so I probably should actually just say an approximation there. And if we think about this, we don't normally use commas, we use spaces now, but just to separate it out, there's our thousands, there's our millions, there's our billions, there's our trillions. So 1.1 trillion cubic kilometres. Okay, moving on to composite solids now. Much like composite shapes, and we did a bit of composite solids with surface area, we're just taking a couple of regular solids and adding them together or subtracting them off each other. So here we've got a composite solid that looks like it's made up of a hemisphere and a cylinder. So our volume is just going to be the volume of the hemisphere plus the volume of the cylinder. So in this case, the volume of the hemisphere is going to be 1/2 times 4/3 pi r cubed. And the volume of the cylinder is going to be pi r squared, which is the area of the base, times by the height, giving us the volume of that cylinder. Okay, so we substitute in everything we know. That's 1/2 times 4/3 times pi, which is just a number, times, sorry, I got a bit ahead of myself, times 9, which is the radius. And then we're going to add to that pi times the radius squared times by the height. So the height, the height in this case, we need to put the number in there, is 7. So we take all of that and we put it into our trusty calculator. Like I said before, we can use a previous function we've used. So if I go back to this one I had before, I can replace that 12 with a 9, and that's the circle part of our formula. If I go back to the end, but we had used this for a hemisphere, it's got the half in there, and I can just go plus pi times the radius, which is 9 squared, times by the height, which is 7. So I put all that in my calculator, press equals, and I'm going to get 3308.1. And our units are centimetres, so centimetres cubed. Okay. Now this cone, I think I've got the time to go through this. It's not, actually no, I won't. I'll hold off on this one because it's sort of not as well related, and it's probably something I'd rather go through in class, but it was quite a difficult question from 2017's HSC. If you want to have a go at yourself, just remember they've only asked for the volume of the cone. So we don't have to subtract some part of the sphere, and I actually think this was kind of a bad question, and I hope it doesn't come back up again because people got confused about whether or not that sphere on top is part of the cone. But because in maths we use the word cone to mean a very specific object, it doesn't mean that. We're just talking about the cone itself, and we just sort of disregard the sphere, but what we know about the sphere is going to help us work out the volume of the cone. Of course, for most people, that shape looks like an ice cream cone. So it did confuse quite a lot of kids. So I don't think you're likely to see a question like this one again. But the biggest thing you're going to find when you go to look at it is, in order to find the volume of a cone, you're going to need to know the radius of the base of the cone. And that's not something that's actually given in the question, so you'd have to work that out. Just a little pause there as I had to sneeze. So the questions are there to hook into this particular lesson. Have a go at those. Once again, I'll be back on Wednesday, so any questions with those you can ask me. Obviously, Miss Rowland should be in one of the neighbouring classrooms if you have questions that perhaps you're the casual teacher. I don't know who you'll be getting. If it's someone who does maths and is quite happy with this stuff, that'd be great. If not, you guys have the option to maybe go and ask Miss Rowlands if you're not quite sure about something. And I'll see you later.